Hello, good morning everybody. My name is Vishwadeep and I welcome you all on Unacademy Computer Science Channel for unlimited learning. In today's lecture, we are going to talk about very important topic, which is recursion in the tree. Why it is important? Just because maximum number of questions in the interviews which you are going to face for any good product based companies, the questions will be asked from tree and basically from recursion. Like the questions like how to delete all the leaf nodes of a tree, how to count number of leaf nodes in the tree, how to calculate the height of a given tree, how to calculate how many maximum levels are there in the tree, and there are so many such questions like swapping of the nodes, like making the mirror image of the tree, and so many such questions are there. Among those questions, we are going to talk about some basic questions so that you can get the idea that how to solve the recursion in the tree, and based on that definitely you will be able to solve any new questions if you have a good understanding of all these questions which we are going to discuss today. So without any delay, let's start the session. So okay, let's go first my introduction. The people who don't know about me, my name is Vishwadeep. I have experience of almost 13 years, 9 plus years in GATE and ESE itself for teaching the only engineers. I am having the experience. My masters from IISc Bangalore, GATE exam I have written multiple times. This is 19th rank I was having in my final year. Before that in third year 682. Apart from that 119, 440, and there are few more ranks I am having under my belt. You can see these are the courses which I have taken or I am taking on Unacademy's platform for you guys. Another opportunity you have for your learning, and go and watch my free lectures on Unacademy's special classes also. Go to the unacademy.com or Unacademy's learner app you download and check out my profile Vishwadeep Gothi. Check out my profile, follow it over there, and you will be getting special class section. Go to that section and you will be having so many free classes which I have taken, plus you will be getting all the notification of all my upcoming free classes. Right now in the special classes I am running this data structures revision session. So you can attend those classes live, you can ask some questions over there, you can some doubts to be solved, and all those things are there for free. So you can go and check it out. Okay, and other than that, we have brought for you guys very special free classes also and free test series also. This particular test series is absolutely free. 21 tests are there in this particular test series. Go and enroll for it. You will get quality questions over there and you will get a really good assessment of your preparation. If you want that in the last few months your preparation to be very great, very good, better than all other members who are not preparing well or who are trying hard well, among those, if you want to be in the topmost guys who are preparing really best, then one option you have is Unacademy Plus. You take subscription of Unacademy Plus. Over there we will provide you live classes which you can listen in, of course recorded mode also, but those classes are such kind of classes more interactive that you will learn in a particular closed very effective environment, that your learning will be best. There will be so many doubt sessions, there will be so many daily practice problems and so many other things you will be getting on Unacademy Plus, and that particular Unacademy Plus subscription you can take using the code VDEEP10. अगर आप ये code use करोगे, you will be getting 10% discount, plus you will be getting my team support. This particular code is not the code, it's an emotion which will connect your preparation to my team's hard work. याद रखें, this particular VDEEP10 support for your GATE preparation and other exam preparation. One more type of subscription we have from Unacademy's side, which is Iconic subscription. In this Iconic subscription, have all the facilities of Unacademy Plus. Apart from that, we have a personal one-to-one guidance coach facility. particular coach will work on. This particular coach will work on your personalized preparation strategy. So based on your own queries and questions and your regular routine, you will be getting your own regular plan for the preparation, your own study planner, study booster session, and for yourself you will be having personalized test analysis so that you can analyze what kind of problems you are facing in, and based on that you can rectify those problems. So in the iconic subscription, you will be having all the facilities of Unacademy plus extra one-to-one personal coach. That particular coach will give you preparation strategies, study planner, study booster session, personalized test analysis for you only and only for you, and you will be having preparation strategy material, means you will be having your own specialized notes and practice sets so that you will be having your preparation iconic, and of course at the end you will be having your rank also iconic. So to get the iconic rank, get iconic subscription, and this iconic subscription also you can get using the code VDEEP10 so that you can get discount plus other benefits. So if you guys are ready to learn, then do two things today. One, definitely message you are ready or not, and the second thing, you share the link with all of your friends so that they also can join us here. Why I'm telling you today only I am declaring this particular thing, that definitely I'm telling you, definitely one day you will remember my this particular lecture for your interview preparation. If you are going for any interview and if you will prepare some questions and you will see the questions maybe in the preparation or maybe during the interview, you will see the question of this particular type for sure, and when you will see those questions you will make yourself happy just because you have learned a lot about this, you have learned perfectly correctly these kind of things, and you will remember those kind of things always. So I'm telling you, don't miss such kind of sessions when I say that this is gonna be very crucial for your career making. If you are really interested in a really great job in the product based companies, then you need to be very good in data structures, and definitely you need such kind of knowledge of tree recursion and so on, so that you can crack the interviews with very ease. So if you are ready, yes, ready, great, amazing. So basically we have covered some basics of tree, binary tree in the tree traversals, and using the traversals how to construct the tree. We have already done all these things. Now today we are going to first start with a really small topic. First we will talk about this ki how to convert a general tree into binary tree. I'll tell you one thing, we have seen a problem in binary tree, general tree, कि general tree we cannot store in the linked representation. In the linked representation, why? Just because the general tree's number of children are not fixed. Number of children were not definite. Number of children can be 1 2 3 4 5 6 15 20 30. We don't have any idea that a node can have maximum how many children. That is why we were not able to have the linked representation about this general tree. But now what we will do, we will convert a general tree into binary tree representation, and then we will store the general tree into a binary tree kind of linked representation. What is the benefit? Benefit is the application of algorithms will be easy. You know why we use the linked representation in binary tree? Just because any type of algorithm, any type of operation you want to perform on the tree, that becomes easy, बहुत आसान हो जाता है. Like if you want to calculate number of leaf nodes, total number of nodes, maybe you want to go for traversal or any other operation you want to do on Binary tree linked representation makes it easy. So हम चाहते हैं, we want that a general tree also can be represented as a binary tree linked representation. If it is possible, then for us general tree operations also will become easy. So how we represent a general tree into binary tree? We have the name. We have the name of this particular conversion or representation, which is called as leftmost child right sibling representation. Right sibling representation. So it's a name of representation, that how you represent a general tree into binary tree type linked representation. It's a leftmost child right sibling representation. Okay, let me make it more clear so that later on you will be able to read it properly. No, so child, leftmost child will come into the left. In the right side, what will come? Sibling. I will give you one example and you will understand this method perfectly. कैसे? Okay, देखते हैं. Let me take a simple example. Suppose there is a node A which is having 4 children B, C, D, E. C is having 2 children E. Let me make it as F and G. Then E is having single child H. H is having 3 children I, J and K. This is the tree. This is the tree. I want to represent this tree into this representation. Leftmost child, right sibling representation. Leftmost child, right sibling representation. Right. So suppose this particular tree is given. Of course, there will be a pointer here or there will be something to start with the root. Root is A. Abhi A se hum jayenge. A is here. Fine. Now from A, whichever from the left side, which is the first child of A. First child of A from the left side is B. That I am going to keep in the left side B. So in the left side we will keep the leftmost child. In the right side we will keep the sibling. Is there any sibling of A? कोई भी sibling नहीं है. There is no any sibling of A, not at all. So in the right side nothing. Now for B, is there any child of B? No. If there is any child of B, it comes in the left. There is no any child of B. So no anything in the left of B. Is there any sibling of B? Starting from left to right. Left to right में कोई sibling है B का? Yes. We have sibling of B, C. So C should come into the right of B. Now for C, what is the first child of C from the left side? It is F. So F should come into the left of C. Is there any sibling of C? Yes, which is D. So D should come into the right. Right में आ जाएगा sibling. Now from D, is there any child of D? No. So left side of D empty. Right side of D, sibling of E, which is E. Now for F, is there any child of F? No. Is there any sibling of F? Yes, G. For G, is there any child? No, nothing in the left. Is there any sibling of G? No, means nothing in the right of G. Now for D, is there any child? No. Sibling? Yes, I have already done. Now for E, is there any child? Look at this. In this diagram, I have drawn the single child of E into right side, but left say from the left side, which is the first child of E? First child of E is single child H. So first child should come into the left only. I will represent H in the left. Is there any sibling of E? Nothing. H, what is the child? First child from the left side of H, I. And is there any sibling of H? No, nothing. No any child of E again apart from H. No sibling of H. So I, is there any child of I? No. So left is empty. Is there any sibling of I? Yes. J. So J should come into the right. J, is there any child? No. Sibling? Yes. Sibling should come into the right. ये बनेगा ट्री, एंड दिस ट्री इज रिप्रेजेंटिंग दिस पर्टिकुलर जनरल ट्री इनटू द मेमोरी. सो इट्स लाइक ट्री इज दैट ओनली. यही है हमारा ट्री. ओरिजिनली दिस इज ओनली द ट्री. This we have represented, this particular tree we have represented into this representation. And you know why we did this? So that my application of algorithms becomes easy. Application of algorithm becomes easy. Because of that, I have represented a general tree also in the binary tree kind of representation. If somebody asks me, is B a leaf node? Answer should be yes or no. B is a leaf node or not? B is a leaf node or not? Your answer should be yes or no. Jaldi batao. Your answer should be yes or no. If I am asking B is a leaf node, jaldi batao. Batao jaldi se if B is a leaf node or not. B is yes a leaf node. Kaise pata? Look at this. This is the original tree. This is the original tree. If somebody asks me if B is a leaf node, yes, check out B is a leaf node here in this tree. If I want to check out कि B is leaf node in this representation, how can I check? थोड़ा सा दिमाग लगाओ. Put your little bit efforts and understand. From a node we keep its children into left side only. The children in the left side, in the right side node के आएंगे sibling. Nodes siblings are there. So in the right side sibling of B is there, in the left side child are there. There is no any child, no. So leftmost child pointer is null. Right. So listen, for this representation, if I am having a structure will look like this. Struct general binary tree ka node, and in that particular node I am going to keep three things. Of course, a character type of data value and two pointers. What is the name of pointer? First pointer is struct general bt node star left most child, and other one is same node type. वेरी गुड मॉर्निंग एवरीबॉडी, वेरी गुड मॉर्निंग. आई होप आप सब ठीक हैं और आपकी प्रिपरेशन भी ठीक चल रही है. राइट सिबलिंग. So two pointers are there within each node, and look at this. What is the name of pointer? First pointer is leftmost child, and right pointer is right sibling. So in the right pointer we don't keep any child ka information. All the children of A are in the left of A only. In the right of A we are going to keep the siblings. There is no any sibling of A, इसलिए right में empty है. So if somebody says this is the representation given, and check out that if a node is leaf node or not. To check the leaf node, what you are going to do? To check the leaf node, I'm writing. मैं लिख देता हूं यहाँ पे. To check leaf node, I am checking if a pointer P is pointing to the leaf node, if its leftmost child pointer, is equal to null, leftmost child pointer is equal to null, then we can say yes, P points to a leaf node. Yes, good, nice, amazing. समझ में आया ये? बिल्कुल. अगर समझ में आया है तो एक्नॉलेज करो. इफ यू गॉट इट, एक्नॉलेज मी so that we can have another question. See, I know you might have understood the basic method, but still I want you to solve another question. Question number 2 based on this only. Question: convert the given tree in binary tree representation. Now what you need to do is you need to solve this question for me, and then once I'll solve, you need to just acknowledge that you got the same answer or not. Okay, clear? Got it. Nice, amazing. Now what am I saying? This particular binary tree representation. Okay, okay. फाइन, चलिए तो एक ट्री में देता हूं आपको, उस ट्री को आपको कन्वर्ट करना है बाइनरी ट्री में. सो दिस इज द ट्री बी सी डी ई. दिस इज सी, बी इज चाइल्ड एफ, सी इज चाइल्ड जी एच आई, एंड देन आई का चाइल्ड, एच का चाइल्ड जे के, इसका है एम एन and O. Convert this particular tree into binary representation as leftmost child, right sibling representation. Come on. So, first of all, root A. Leftmost first child from the left, B. Right का sibling A, right sibling nothing is there. B's child, yes, F. B's sibling C. C's child, yes, first leftmost child G. Sibling, yes, D. G का child nothing, sibling H. D का child nothing, sibling E. H का child, yes, J. Sibling I. J का child no, sibling K. I का चाइल्ड M, सिबलिंग नो, M का चाइल्ड नो, सिबलिंग N, N का सिबलिंग O. A B C D E, B F C G H I, G nothing, H J K I M N O. This is the tree. Look at this. If you got the same tree, look at this. If you got the same tree or not. क्या आपको सेम ट्री मिला? क्या आपको भी सेम झाड़ वृक्ष पेड़ मिला? सेम आंसर. ग्रेट, अमेजिंग, सुपर्ब, अमेजिंग पीपल. So if you got this particular thing, now we are going to go for another question, which is a gate question, I guess, and it says there is a function, get value function. This particular function runs on a binary tree. What it returns? What does the following function return on a binary tree? ग्रेट, अमेजिंग, सेम आया. बहुत अच्छी बात है, बहुत बढ़िया. सुपर्ब, अमेजिंग. As the festival season, festivals are approaching, we should intensify our preparations so that if we will lose some number of hours or some number of days because of the festival, those number of hours can be compensated before only, so that our preparation will be on the track. जल्दी से बताएं, ये क्वेश्चन सॉल्व करें and then give me the answer that what this particular function returns. Now listen. First of all, let's take a simple example. I will explain you ki how, if any such kind of program is given, then how exactly you are going to solve it over the given tree. Okay, so I will explain you how to run the recursive program over the tree. Okay, it will be very easy for you to understand just because I know you guys are very quick. So let's say this is the tree. A is root. Okay, let me take the tree here. A is root, left side B, right side C, B is left D, right E. That's it. This is the tree I have taken. Now. Suppose on this particular tree I have called this function. This is the function, get value function, I have called on the root. So assuming that the tree pointer is pointing to this particular node A. So for my assumption, for my understanding, I am saying that I have called get value function on the root, means address of this particular node address of this particular node, which is A. Address of this particular node. Right? So I am just assuming that for address of A, we have called the very first function, first time function, get value function with the root. Okay. So instead of actually क्या होगा? What will happen actually is this function is called for the address of this node, not for the value of A. It will be called with the address of node, but for my understanding, I have written कि for A we have called get value function. मेरा दिमाग चलेगा, आगे बढ़ते हैं. Now integer value is equal to 0. Fine. So in this particular function's execution, the very first thing we have done is value is equal to 0. Value is equal to 0, right? So for this one, value becomes 0, and after that what is there? If t is pointing to not null, yes, t is pointing to not null, yes, correct. Then if t is pointing and its left child is equal to null and right child is equal to null. So if t is pointing to this one and the nodes left and right child both are null, है क्या अभी? है क्या A's left and right child both are null? No. Condition false, and then in the else case we are going to call value is equal to value plus get value of left child plus right child. So next we are going to call value is equal to value, which is 0, plus get value function with left child, which is A's left child is B, plus get value function with right child C. You need to do this. Let's do that. Let us do that. So if we are calling the get value function with B, initially of course statement is written value is equal to 0. Find value is equal to 0. Okay. Now t pointer is pointing to this node B. Is its left and right child both are equal to null? No. If both are equal to null, no, then what you gonna do is else case is value is equal to value plus get value function for left and right child. Okay, do that. So I am calling value is equal to value plus, or value initially 0, plus get value function with left child of B, which is D, plus get value function with right child E. Got it? Now for D you need to call this get value function for D. Value is equal to 0 initially, yes. After that D is pointing, means my current pointer T is pointing to this particular node. Its left and right child are null now. D's left and right child are null now, yes. So condition is true. Currently my T pointer is true. I'll come inside, T's left and right child both are equal to null. Yes, condition is true. When the condition is true, means I will set value is equal to 1 and function finish. So I will set value is equal to 1 and then return 1. Return 1 means this get value function of D will get a value 1. Now I'll call get value function with E. Yes, I will do it. So let's go for this one. Initially value is equal to 0, right? T pointer now pointing to this E. T pointer now pointing to this particular E, fine. Now what I will do, I will check out कि T is true. Yes, pointing to E node means true. Is left child and right child null? Yes, true. Left and right child both are null. You can check out. क्या सही है? Is that true? Is left and right child both are null? Yes, null. Then what I will do? Value is equal to 1. I will set value is equal to 1 and then return value. I will set value is equal to 1 and return value means this get value for E will return you 1. So this value becomes 1 plus 1, 2, and from here you will return value 2. So value 2 return करेंगे यहाँ पे. Get value for B has returned value 2. Now for get value C. Get value C, if you are calling for C, T pointer points to this particular node C. Initially value is equal to 0. T pointer pointing to this, check out the condition कि क्या left और right child दोनों null हैं? Yes, null हैं. Then value set to 1 and after the if return value. So value becomes 1 and return value means get value for C returns you or gets you 1. 2 plus 1, 3 will be set here, and for root, this particular function returns you value 3. Now, what is this value? Yes, Nikita, exactly this value is number of leaf node. What it returns? Number of leaf nodes. So I am writing the answer here. It returns number of leaf nodes. Now look at this. Look at this. This particular function you should be able to understand directly without even executing such function or without drawing the recursion tree. What I am doing, if you have called the get value function with a node t, node pointer t, if pointing t is pointing to the node, I am checking if t is pointing to a node which is leaf node. You know that this is the condition for checking the leaf node. If t is pointing to a leaf node, then value becomes 1. Right? If t is not pointing to the leaf node, then recursively I am calculating all the leaf nodes in the left child. Then recursively I am calculating all the leaf nodes in the right child. Total number of leaf nodes in the left child plus total number of leaf nodes in the right child will be total number of leaf nodes in my entire tree. Right? Now listen what happens. Suppose this is the root. From here I want to calculate how many leaf nodes are there total. So I will do what? I will check out if this is itself is a leaf node. No, it's not a leaf node. Then recursively you call the left subtree. Left subtree, calculate number of leaf nodes in the left subtree. Then recursively you calculate number of leaf nodes in the right subtree. Once number of leaf node in the left subtree and right subtree are calculated, then sum those two. Add those two values and you will get correct answer. So one learning which I am telling you now, and that particular learning will help you a lot for you to understand the recursive algorithms on tree. The understanding is the basic of recursion. The basic of recursion lies in the base case for tree. The basic, the understanding, the meaning of recursion on the tree lies under the base case. If the base case you are able to understand, then you can understand the recursion easily. So for base case, when we have reached to the leaf node, what should I return when I have reached to a leaf node? If I have reached to a leaf node, then I will return value 1. Otherwise, I will recursively call the left subtree's number of leaf nodes. I will calculate recursively right subtree's leaf node and I will add those two. Look at this. You can see here, for when you have called get value function for a के left child में, look at this. How many number of leaf nodes are there in the left child of a? 2. This and this. So you can see that for get value function you have called for b, you are having 2 leaf nodes. Get value function for b, you are having 2 leaf nodes return. Second thing, if suppose you are calling for right child a के right child में only single leaf node is there, means this. So you need to understand the base case. If you understand the base case, then the recursive algorithms will always be easy for you to understand. Fine. Okay, there is a small extra thing they have given in this particular question, this value plus. If you will not even add this value plus, that is also fine for this algorithm. Just because they wanted something extra, They wanted something extra apart from the people know. Usually people sometimes know that this particular algorithm works for what, calculating the leaf nodes. So sometimes they may give some extra things, some extra variable or some modification, so that people will be confused कि अच्छा ये तो हमने पढ़ा ही नहीं, वैल्यू ऐड क्यों करते हैं, क्यों करेंगे, वैल्यू ऐड किया कुछ तो गलत होगा, right? Right. Now what happens, look at this. Sometimes, okay, one question is there, sir, if we will not write if t, then that will work. Look at this, buddy. Suppose here we have this particular b, and for b we don't have this right child e. For b we don't have any right child e. B is leaf node? No. If B is not leaf node, I will call for B's left child and right child both. Yes, when I will call for B's left child, I will be getting D. Yes, but when I will call for B's right child, I will be getting null. So if only single child is available and you are calling for that single child null, then my function should return 0. That is why that condition is written. If you have called the function for null pointer, then I should return 0 number of leaf nodes from that. Because of that, this particular condition base case is written. If you have called somehow with the null pointer, then I should return value initially 0 only. That is why we have written it. Okay, got it. Now if you are understanding this, then it will be really easy for you guys to understand further few more things. Next thing we are going to check out is this function. Now this function is again a recursive function, and I need to execute it on the given tree. How this particular function works, apply this and get me the answer. Get me the answer. If you can understand how this function works on the tree, you can directly give me the answer. If not, then you can apply the function one by one step, and you can get me the correct answer at the end. Try, understand, and let me know what is your answer. So consider following routine on binary tree. This is the routine. If you have called the function with non-empty node, means for a tree, usual tree, then first of all you need to do something on left child, then something on right child, means you need to recursively call for left and right child. Once the left and right child recursive call done, after that you need to swap the left and right child pointers. So from A, if you are calling the function as root t, first of all do something on this, then do something on this, and after that swap these two. Swap these two means A's left child becomes D and A's right child becomes B. Swapping is what? Left and right child pointers will be swapped, means A's left child becomes D, right child becomes B. But before that, you need to call for B and D as root, and you need to do something, the same thing similarly till the last. Got it? Now this particular function looks like a post order traversal. Is that so or not? क्या ये post order traversal नहीं है? Post order traversal, yes, it's one of the modification of post order traversal, and that particular modification says that first of all you do something on left subtree, then do something on right subtree, and after that for the node swap the left and right child. If you will swap the left and right child, but before that you need to swap the further left and right subtree all the children, what output you will be getting? What output you will be getting? You will be getting the output like this. You will be getting the output like this. A's left child is D, right child B, and D's left child becomes C, right child null. D's left child becomes G, and right child becomes E. E's left child becomes F, and right child becomes null. Got it? All the children, left to right, right to left, we have swapped. All the children we have swapped. Okay. I made a mistake. I made a mistake. Yes, yes, yes. I made a mistake. I made a mistake. I made a mistake. I made a mistake. Blunder. I made it. Blunder. I made. So you had D's left child and right child G and E, right? So here it is G and here it is E. And E's left child becomes F and B's left child is right now, right child is C. So left child becomes C. This will be the tree. This will be the tree. So, okay, let me draw it here only. Let me draw it here only. A is root. Fine. Left and right child swapped D here, B here. B's left and right swapped means, first of all, B ka right is C, so it becomes right to left and right becomes null. Similarly, D ka left child is E, it becomes left, right and left goes to G. E's right child is F, so it becomes left child. This will be the tree after entire swapping. And this is nothing but, this particular tree is actually doing what? It's giving you the mirror image of the tree. Mirror image of tree. There is another question. There is another question we can have, and that particular question can be कि make a copy, original copy, duplicate copy of the given tree. So if this is the tree, another tree you need to construct and you need to make as it is copy of this particular tree recursively. So take the root, copy its left and right child into the tree. You can do it, yes, and then call for left and right child. So first of all, take the root, its value, key value you copy on the root here and call for left and right child. Then similarly, copy value of B here, copy value of D here, and then again call for left and right child, and it goes down, 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 down. So you need to just understand. You need to just understand the function, and your solution can be on your fingertips easily. चलिए, अब बात करते हैं how to calculate height of a binary tree recursively. This is one of the seriously very easy, one of the very easiest kind of solution. I will explain you first using an example. After that we will try to get out of this some kind of algorithm and recursive algorithm. Fine. So look at this. First of all, a tree is given to you. Let's say this one. So you have a tree like this: A, B, C, D, E, F and G. This is the tree. Suppose with single node height is 0, assuming, okay. Single node height 0 means empty tree height will be what? Batao. Tell me what will be the empty tree height. Empty tree height will be -1, right? So when you have empty tree, its height should be -1, single node height 0. What is the height of this tree? Can you tell me? What is the height of this particular tree? Batao. Height of this particular tree is 0, 1, 2 and 3. 3. Height of this particular tree is 3. Now, if I have passed only the root, of this particular tree to your algorithm, how my algorithm initially can see कि which side you will be having more height. In the left side you will be having more levels or right side. Just because whichever side you have more levels or more height, that will affect my final height of the tree. है कि नहीं? जिधर ज्यादा हाइट होगी उधर की साइड ही, आपकी हाइट डिसाइड करेगा ट्री. So from root, can I detect which side, left side or right side is having more height? I can't detect initially by just having only root of the tree. सिर्फ root है तो नहीं पता चलेगा. तो हम क्या करेंगे? What we will do? Recursively we will calculate the left subtree's height. एंड रिकर्सिवली वी विल कैलकुलेट राइट सब ट्रीज हाइट। ठीक है, तो मैंने क्या लिखा, अगर मैंने लिखा है इफ आई हैव अ रिकर्सिव एल्गोरिथम फॉर हाइट कैलकुलेशन ऑफ अ ट्री with pointer t, I will first calculate, suppose like this, height of left subtree hl by calling the same function height with t का left child, और साथ ही साथ I will calculate hr also, which is recursive call of height function with t's right child। तो मैंने पहले रिकर्सिवली लेफ्ट चाइल्ड का हाइट कैलकुलेट किया, लेफ्ट सब ट्रीज हाइट कैलकुलेट किया, देन राइट सब ट्रीज हाइट कैलकुलेट किया। नाउ इन दिस पर्टिकुलर केस व्हाट इज द लेफ्ट सब ट्रीज हाइट, what is the left subtree's height? 1. What is the right subtree's height? 2. 0 1 and 0 1 2। अभी तो आपको दोनों का हाइट मिला, you got left subtree's height, right subtree's height, yes, what is the overall height of the tree? So overall height of the tree will be decided based on which is larger value, which tree or which subtree is having more height. Based on that you are calculating, yes, so my height of the tree h will be equal to the maximum of these two, hl comma hr plus 1। दोनों में से जो मैक्सिमम है 2 प्लस 1। वाई प्लस 1? अरे यार सब ट्री का हाइट तो यहीं तक है ना, स्टार्टिंग फ्रॉम ईदर बी और सी। मुझे चाहिए स्टार्टिंग फ्रॉम ए, I need the tree's height starting from A, तो include this level also. So if I'll include this level also, plus 1 कर दिया। So what is the maximum height till here? 2. So if till here maximum height is 2, then starting from A, my subtree, my tree should have height 3. Yes, maximum of left subtree's height plus right subtree's height plus 1. That will be your height. But suppose you are going down and down, and before that or after that, when you are going too deep and at the end you reach to null. When you reach to null means you have called the height function, with empty tree. So if you have called the height function with empty tree means t is equal to null. For empty tree what should I return? For empty tree, what should I return? For empty tree, I should return what? For empty tree, I should return minus 1. So when you have called the height function where t is equal to null, then return minus 1 and done. Your height of the tree calculated. But if t is not null, then calculate left subtree's height, right subtree's height, and then calculate this maximum of hl comma hr plus 1। आपको मिल जाएगा height और at the end return कर दो ये h। That will be your height function। Yes Bhaskar, yes Nishu। Now this is that particular algorithm। So you have called xyz, xyz मतलब height function, okay, with pointer t, not of t मतलब क्या? If not of t means t is null। when t is null this condition true, return 0। अभी थोड़ा change है। This particular algorithm does what? This particular algorithm calculates height of tree when for single node height is 0, for single node height is 1, for single node when for single node height is 1, when single node height is 1, for single node height 1, and for empty tree height 0, and for empty tree height is equal to 0। तो अगर आपने if you are returning 0 for empty tree and remaining logic is same to same, see xl is left child का value, XR is right child value, and you are calculating if XL is greater, return XL plus 1, if not then return XR plus 1. Maximum you are returning plus 1 return. So if t is equal to null, you are returning 0, means height definition other one you have taken with single node height 1 and empty tree height 0. For empty tree you are returning 0. If you want the other definition for empty tree height -1 for single node height 0, then you can write this algorithm. Instead of here 0, you can return -1 when you are calling the function for null. So small changes you can do, and based on that you can write the algorithm for every problem, every definition of height and every problem. Yes, Nishu, exactly. Everybody convinced with this particular algorithm, understood how to understand the algorithm, how to understand the recursive algorithm. If you are fine with understanding the recursive algorithm, then definitely I'm telling you the tree recursion will be on your fingertip, and any kind of tough questions you will be solving like a pro. Okay, bro. Now, another type of question, and which is again very complex question. This is a question of indirect traversal. Indirect recursion, indirect recursive functions for traversal. Got it? Now, what is this? See, m function you have called for pointer t. If t is true, you are calling the function like in-order traversal, but instead of calling same m function, you are calling n function. You are calling function n. Here also. So from m you are calling function n. Here is the function n, almost same type, little bit variation. What is the variation? If you are calling a function with pointer t, n function, it is almost same. If n is true, you are calling it in pre-order way, but instead of calling same function n, you are calling function m. Function m means indirectly m is calling to itself. So first m is calling n and n is calling m. Similarly, indirectly n is calling itself. How? N is calling m and m is calling n. What I need to calculate is, if I call the function with m function with root, then what will be the result? There are two ways to solve this question. First one is draw the recursion tree and solve the regular way. Like this way. If you will be calling first of all m function with t, m function is in order way. So it says first of all you call n function with n function. Now from n to m to n function with left, which is b. So you have called for a. Then after that you print value of root a, and then n function you call for the right child c. Now for b you will have to execute function n. You need to execute for b and keep going downside. But I would not like to go with this regular method. Not at all. Okay, let me draw the tree once again. Here it is like this way. A, root, left side b, right side c, then d, e and f. So b's left child is d, right child e, and right child f. This is the tree given. Look at this. First of all, if you are calling m function, right? M function is of what type? What type of traversal? In order, pre-order, post-order. You tell me m function. This function is of what type? In order, pre-order, post-order. You only tell me. It is in order type. In order type means if you are calling for this root m function, then you need to put this particular a's printing as in order way. Means a will be printed after its entire left subtree is traversed somehow. If you remember my dot method, you will remember this particular point. Key a will be printed in order way, means I'll have to in order way. M function is pre-order. M function is pre-order. No, in order. In order means I need to, on the root level, I need to print root value in the in order way, means I need to put the dot here. Fine. From this root, you have called function n and n for left and right child both. For function n and n, both n and n function, and for left and right child, means for b and c. For b and c, you have called which function? N function. Means for b and c, you need to traverse b and c in which way? What type of traversal it is? It is pre-order traversal. So n is pre-order traversal, means b and c you need to traverse like a pre-order traversal. You need to traverse like a pre-order traversal, means you need to put the dots for b and c as pre-order traversal. Done. Now next, for b when you have called m function, for b you have called this executing, so from b you are calling m function for d and e. For b you are executing n function, yes. Under n function you are calling m function for left and right child, means for d and e you will be calling m function, means in order way. For d and e in order way. Similarly for c also you will be calling for f in order way, means on the next level you are calling the function in order way. Done. It's a regular execution, left to right. Yes, left to right. So take a strolling from left to right, and whatever the sequence of dots we will encounter, that is our correct answer of traversal. And what is the traversal sequence we are getting? Answer is B, D, E, A, C, F. B, D, E, A, C, F will be the answer. B, D, E, F, C. B, D, E, F. B, D, E, A, C, F. B, D, E, A, C, F. B, D, E, A, C, F. BDE SEF. Yes, correct. If you got this point, then I guess next question you can easily solve. Now I am calling first of all function n for the root. Function n, if I am calling this one, this is pre-order. This is pre-order, means for the first level I need to print, or I need to traverse for pre-order way. Next level will be traversed in order way. So B and C will be traversed in order way. Put the dot in order way between left and right subtree. And after that, on the next level again in pre-order way. So level wise level, you can put the dots in order, pre-order, like that way. And now take the sequence from left to right of the dots, and you will be getting the correct answer. So what will be the traversal here? Traversal will be A, D, B, E, C and F. A, D, B, E, C, F. Correct, Nikita. Exactly. Amazing. Superb, amazing. If you guys are understanding this, then this question again, another question. M of T function. M of T function you need to call on this particular tree now. M function is in order. In order. In order means that put the dot here, in order way. Next function n function is pre-order, so next level pre-order. Then on the next level in order way, between left and right subtrees, then pre-order way. And get the traversal done. So level wise level, on particular level you take that particular traversal, and on the next level alternate traversal, and keep going. What will be the answer? B, D, E, A, C, F, G. C, F, and G. B, D, E, A, C, F, G. Good, Nishu. Good, Nikita. And such kind of so many questions you can solve. And such kind of so many questions you can solve. Now I am giving you one homework. If you are really interested in learning the recursion, I am giving you a homework if you can do this particular question by yourself. Write a recursive algorithm to delete all existing leaf nodes. So you have a tree. In that tree you have some leaf nodes. You need to delete those leaf nodes. You need to delete those leaf nodes. Okay, so if you need to delete those leaf nodes, how you will apply that particular algorithm, that will be amazing. Yeah, okay, clear, got it. Now what is next? So today's session is over. What is next? In the next session we are going to see the expression trees, full binary trees and complete binary trees, how these are implemented, some properties, explanations, number of nodes, and something. There are so many small things in this. And apart from that, after that we will go for binary search trees and AVL trees. So these are the next few things which are lined up for the next sessions. These my COA will get over today. Discrete math already got over, and this is also getting over almost in a few days. So you are going to have 3 new courses once these particular courses will be done. So 2 courses are always already done. Let's have 2 days break for your evening gate express batch, just because so many students requested us ki sir, we will be having the festival season, so evening classes can you make little bit rescheduled. So we are thinking to have a 1 or 2 days break for the festival time, so that you can enjoy your festival, and after that once again we will come back with more intensity, new subjects, new topics, new schedule, and you will love that particular schedule. Of course I'll be coming live to give you all the schedule and their detail, ki which time will be having the next class or next subject, what time will be there, everything I'll be telling you. Yes, correct. So how many sessions DS will take to complete, Nishu? I don't have any idea, just because for these sessions we don't plan a particular complete execution. It's a regular batch class, so it's going on. Whenever it will finish, it will finish. But I am just planning few of the lectures in the future only. So once these lectures will be finished, I guess 15-20 lectures more will be required, and we will be able to do it. 15 to 20 more lectures I guess will be required, and we will be doing it. This is the team, as I was talking about. This team is working hard in and out for you guys. आप लोग थोड़ा efforts लगाएं, learn live, enjoy these live sessions of each and every teacher, so that you will be learning effectively and in better mode. If you like the sessions of somebody's, please like the videos, share those videos with all of your friends, so that those people also get benefited out of it. If you want the PDF of the lectures, you can join us on this particular Telegram channel. Over that we drop all the PDF of the lectures. Will you cover graph in this series? I will cover graph, but I will cover only graph ka BFS and DFS. Other things we will cover in the algorithm chapter. So if you have graph algorithms like MST algorithms and shortest path algorithms and all, वो हम graph के algorithm में देखेंगे, algorithm में देखेंगे डा जो आपका कोर्स आएगा उसमें. ठीक है. If I'll be teaching algorithm, I will be teaching those topics on again. If I'll not be teaching, somebody else will be teaching, then that fellow will cover all those, but will be covered definitely. This is the channel Creatrix for and ECIN एंड इलेक्ट्रिकल मैकेनिकल के लिए ये चैनल है, सिविल के लिए चैनल है, SSC JE के लिए चैनल है. वी हैव जनरल स्टडी GS टर्मिनल ऑल्सो फॉर कंप्यूटर साइंस, योर ओन चैनल. इट्स योर ओन चैनल. वाई? जस्ट बिकॉज वी आर जस्ट प्रोवाइडिंग यू द lectures. We are just providing you the service. You are the owner. You are the actual people who are actually owning this particular channel. So keep this particular channel as in your mind as your own channel, and please work hard to make this particular channel spread about, or to make this particular channel available for each and every person, reachable to each and every person who is in computer science. Keep liking the lectures, keep sharing the sessions, subscribe the channel if you haven't done, and turn on the notification so that you will get notification of all our classes when I'll be taking, or other fellows will be taking, the live classes. Okay, thank you so much for joining here. Happy learning. Have a remaining day nice, and 12 p.m. again we will meet for what? PYQ session. Previous year questions का session है on the Q. So we will meet again on 12 p.m. Up to then, bye bye.